So let us move on to the question A here. So suppose we are given the vector A is like this. And the vector B is somehow like this. Right. And they are at the same plane. Then it is at the same plane than the normal vector. And here, the normal vector of the plane here, alpha, will be perpendicular to any vectors here, right? Or we see that remember the cross product properties. A cross B will become, let us call it the vector V. Then vector V will be perpendicular to vector A, and the vector V will perpendicular to the vector B. This is the properties of cross product. It means that we need to find the non-zero vector of this perpendicular to vector A and vector B, which means we need to find the cross product of the vector B and vector A here, right? Remember the cross product of this guy, of the vector A times cross vector B, we can do it this way. We can write it as the determinant of vector I, vector J, and vector K here. Of the vector A, where A is 3, -5, and 4. And vector B here is -2, 1, 3. Okay. Remember, it should be written in this order. If you change the order, B first and A later, the result would be negative of the correct one. Anyway, the determinant of the order 3 gives us that it would be the determinant of this guy, -5, 4, 1, 3 times the vector I. Okay, when we expand the I column here, the I position here, we cross the column containing I and the row containing I, which leaves us the determinant of order 2 here. And similarly, remember the second guys, it is the determinant of this expanding in J direction. But there's a negative sign here. And the same story will be determinant of 3, 4, -2, 3. Okay? And we expand in K direction. Position K here, right? We will cross the column containing K, which leaves us 3, -5, -2, 1. Okay. Or it will be -5 times 3, right? Just remember this rule. Multiply this here and subtract this guy. This rule. Okay. Then it becomes -5 times 3 minus 1 times 4 times vector I. The second guy, okay, the second guy will be subtract 3 times 3 minus negative 2 times 4 vector j plus here 3 times 1 minus negative 2 times negative 5 times vector k here. Okay, simplify it. 5 times negative 3, negative 5 times 3 is negative 15. Negative 4 will be negative 19 pi minus here. It will be 9 plus 6, it will be 15 j. And 3 minus 10, it will be minus 7k. Okay, or we can write it in vectors term. It will be negative 19, negative 15, and negative 7. So the vector the non-zero vector V is satisfied the requirement. It's satisfying the requirement, right? We can double check it. Okay? You don't have to double check it here in the test, but let us double check it now. So if V is perpendicular to the vector A, right? Then V dot A should be 0. What is V? V is negative 19, negative 15, negative 7. Vector A, what is it? It is 3, negative 5, 4, right? It will be negative 19 times 3 plus negative 15 times negative 5 plus negative 7 times 4, right? What is it? 19 times 3 will be 57, negative 57, plus this is 75, this is negative 28, right? There's something wrong somewhere. Did we do it right here? Yeah, we added wrong here. This is 9 subtract 8. 9 plus 8 will be 17. Yeah, my bad. Okay, this is 17. Yeah, we did a mistake here, so be careful in the test. 17 times 5 will be 85. Yeah, it is 0. So, and furthermore, v dot b, let us double check, right? Negative 19 times negative 17 times negative 7 times, here is negative 1, negative 2, 1, 3. Yeah, it will be negative 19 times negative 2 plus negative 17 times 1 plus negative 7 times 3. Oh, I'm hungry, sorry. So it will be 38. Negative 17, it is negative 21. Yeah, correct. It's 38. Minus 38 is 0. Okay. So we are done with the question 8.